sure familiar with CubeSats. They're all set like 10 centimeters by 10 centimeters by 10 centimeters. And it's something like a payload of about 1.3 kilograms, the maximum. And so what we had to do is this, because we don't have the kind of funding that a lot of people have, we have to design and build everything ourselves. And so what happened is we have teams around the country that do different things. Like we have a student at University of Stellenbosch that developed a total new concept of a modular space frame. Now a space frame can cost you something like 40,000 rand for one, and you need about 3 or 4 because you go at various stages and then you have your final launch model. But as part of all that, we have an electronic control system that controls the battery power, the charging from the solar panels, those kind of things. That's complete. We also have a stabilization unit which Frick is responsible for, and he's developed that, and that's complete. And we're now at the stage where we have the third iteration of the transponder, and we asked Leon to come and just have a quick demonstration and that's the first time that anybody outside his workshop will see that it works. So please, I hope it's not like the projector.
No, I just tested it. It makes feedback. Okay. This down here. Okay. I'm bad at doing what you would call it. I just put a picture of this thing. Don't worry about that. That's just a little Arduino that configures the hardware on the transponder. You'll see there's my semi-rigid line, and I've got RG 316, I think. No, that's not 316, it's something else. I found it in the workshop. It's Teflon cable, and I use Teflon cable extensively because you can apply copious amounts of heat to it, and it doesn't shrivel up and go apart. The AGC circuit I haven't configured. Hannes summed it up on Monday's meeting that I've got a fridge full of gain here. There's roughly about 140 dBs of gain on this board, potential gain on this board. And once you start talking 100 dB gain, you're getting into the realm of oscillators. You'll notice that you guys can come and have a look at the board. I'm just asking that previously we had the board with cheap components on it. If you wear any nylon or stuff, please don't handle the board. It is static sensitive. I wear cotton. So, and I even sometimes write these things off. So the idea here is you guys can also see here I made a crystal filter because the previous 45 megahertz filters gave us slight trouble. So I used two 40 megahertz fundamental crystals. You cannot use third or fifth overtone crystals for filters because they will work at their fundamental frequency. This is actually two 40 megahertz fundamental crystals. And there's no rocket science on it. I took two crystals out of the tray, I put it on the instrument, and I saw, oh boy, the filter is not 49 meg, it's 39,995 megahertz. So that's no problem because we've got a fractional synthesizer on the board. So I stuck it into the Arduino. So the IF frequency is actually 39,995 megahertz. So you got to adjust all the stuff, but currently the input, you guys can actually test it. The transponder input is 434.100 FM or SSB if you have got a SSB radio, and it will transmit on 145.900. So let me just quickly fire it up. It outputs currently about 10 milliwatt, which should be enough for. Okay, there we are. And way I test these things. Hello. I've got a patent on feedback. All the repeaters I work on, whenever you hear a guy saying hello and there's one massive feedback on it, you know Leon is on frequency, I don't have to give my call sign. Couple of things that we found with this thing. RF engineering is at best a black magic. I said to someone this morning, if we lived in the medieval times, they would have taken all the RF engineers and stuck them on the stake and burned them. Because I've done a lot of RF design, microwave stuff. This transponder is a different way of thinking. It's not as simple as people think, and this is why you do not find transponder designs on the internet. Other thing is we've got two mixers in it. Because we have got two mixers, we can configure this transponder to either be an inverting transponder or a non-inverting transponder. Currently it's configured as an inverting transponder, which means if you send upper side band in on 434-100, you will get lower side band out on 145-900. Most tank plants are configured like this, so but when we get closer to production time, we will probably decide what way we're going to do it, but we have got the choice of either or, and it all comes in just, the advantage here is that I've got two mixers. Because I've got two mixers, I've got the option of going either inverting or non-inverting. Other than that, there's not much we can say. We've got to obviously spin a new PC board. We found some things with the MOSFET amplifiers that was a little bit disturbing. The bias values of the MOSFETs are not, because we're not running Class C amplifiers, we're basically running modified Class A amplifiers because we need linear amplification. And one of the reasons I have not populated the AGC side of it is I'm using an AD8307 to measure the output power with. The problem with that is it's not a true RMS power meter. So basically what happens, it actually does a jipper, it actually measures the voltage. Which means if I have an SSB signal coming in, I will actually overdrive the transponder, because I cannot measure the true power coming out of the PA. We will have to go for a different device, which is probably a true RMS power meter. We're designing the transponder that we can have more than one SSB signal coming in. Currently the bandwidth is about 25 kilohertz. Hannes, I think, said our target would be 50 kilohertz or something like that.
Minimum 20.
Minimum 20. So we're 5 kilohertz above the minimum 20 kilohertz. If you're willing to take a 3 dB knock, you can take it up to about 30 kilohertz currently. And that's just with my two crystals.
What is your uplink? Can I call you?
Yeah, you can call me. My uplink is 434-100. And my downlink is... Hello. My downlink is 145-900. 434-100. And there's certain things that you learn about these very specialized mixers. I said to Nico today,
AKV calling.
Here we are. We are receiving it. And this radio is set for narrow. That is why you sound so terrible, because obviously
I normally sound terrible. The 6 AKV calling the AMSATSA transponder, and of course we got some lost feedback. You see, this signal's too strong.
oh, Yeah, well, the way we're overdriving it currently, it will work like a cheap Chinese radio because it's generating a lot of harmonics. So hopefully there's no one that's going to give us trouble for. I'm just checking now for my wide and narrow here.
Leon, he's spinning it.
Oh, it's working at least on 20 meters. So,
20 meters. So shall I go outside and see how
you can go outside. Yeah, let's see how sensitive the thing is.
You have to talk back to me, otherwise I won't know.
It is slightly deaf, but I think for all practical purposes.
Calling outside. I don't have the setup here to receive everything. So, yeah.
Hans is doing radio.
Okay, Hans, at least we can hear you. Yeah, looks like it's working. The worst of all is using for the reception, I'm somewhere using a Wi-Fi antenna. So the radio doesn't perform that badly considering that we actually don't really have an antenna on the receive port. You'll see the receive port is this one here. And the transmit port, obviously, I just use the normal handheld antenna. So yeah, that's the long and the short. So now we're going to spin the new PC board with the telemetric stuff on it. And then whatever I messed up here, we will probably go for a discrete filter at the end of the day. Getting hold of these specialized wide crystal filters there's a company in Taiwan that makes them, and it's difficult because we only need 5 or 6 filters. We need 10 at maximum, and getting 10 filters from a company that builds millions of filters per day, you definitely have a problem in acquiring the stuff. So I'll see what type of fundamental high frequency crystals we can get and see if we can spin our own filter. So spinning your own filter, I mean, I've got the space, we've got the real estate on the board, so it doesn't matter, I don't have to use an integrated filter, we can run a discrete filter. It just means that before flight, when they build the board, when we got to do this stuff, we're probably going to have to work in a clean room or something like that to tune it up. Hopefully they've got instruments in their clean room that we can use. I know my instruments won't work there because it's HP stuff, and HP test equipment are stoves because they consume huge amounts of power and they have these huge fans on them. And usually in a clean room you don't want something with fans on it. So yeah, that's about all I can say. But you guys are welcome to come and have a look at it. It looks a bit messy with this umbilical cord hanging off.
Smoke coming out of the
Yeah, well, you see what is Jacques said to me, don't let Hans touch your transponder because when Hans touches them, the magic smoke comes out. But in Hans's defense, I must admit, he did ask whether he can put 12 volt on it, and they said to him yes. In the meantime, that's why I put a USB connector on it and 5 volts, so that they cannot put a 12 volt power supply on it. Okay, here we are.
Okay, Bill, thank you very much. I think what we're going to do is this last script to see he's here and he's got all his goodies here, his toys. Tell you quickly, how do you keep a satellite like in orientation and how do you stop it from spinning? So it goes about 5 minutes before we break, and then we try and sort out this. We have the next presentation that should have come before Leon sorted out on the other laptop, and then hopefully we can get Anton sorted out during the tea break. Right, Meneer Wolf.
Thank you, Hans. My name is Frik, 06FZ, for those that doesn't know me. I've been tasked to do the magnetic stabilization on the CubeSat and also the solar panels Now, first I want to start off with the solar panels. There's going to be 13 solar panels on the CubeSat. The design, it's very small, and it was quite a challenge to fit 24 solar cells onto this board. Now, 8 of the solar panels is going to be the door, which is side by side, and it will open up this moment the satellite has been launched. And then I'll have 5 stationary solar panels on the sides of the CubeSat. The output of this is somewhere in the region of 14.6 to 14.4 volts at least half an amp. It's all going to be controlled by the EPS board that Fritz is designing and building. So yeah, we're going to have the solar panels, and on the solar panel there is connected to it is the EPS and also the battery that the solar panels will charge. Now, the next important part in the CubeSat is the stabilization. There's quite a few ways of doing stabilization in a satellite. The one is with motors, a spinning piece of weight, or a counterweight you call it, the same way if you know how gyroscope works, that is on the same basis as a gyroscope. The other way, and the cheaper way, is using magnets, permanent magnets, in a configuration like this. This point here can either be 2 north poles or 2 south poles. Now the reason for that is when you launch a satellite, let's presume this box is the satellite. The moment it's been launched, it will tumble in space. Now to get it stable, you need to orientate it with either the south pole or the north pole of the Earth. And by adding this stabilization board, if this is south of the magnets, it will orientate to the north pole of the Earth. So every time there's a pass, it will either flip the satellite, or when it's tumbling, this round magnet here will cut the Earth's magnet field, and it will stabilize it in either this orientation or this orientation. It all depends on what the polarization of the magnet is on this side. The reason for stabilization is so that your antennas is always orientated towards the part of the Earth that you are targeting. In our case, it will be the southern hemisphere, and every time it goes over the equator, it will start going this way and point the antennas away from the northern hemisphere. Otherwise they take up our talking time. And then when it comes around again, it flips the satellite again, and it will favor the southern hemisphere, and we as South African hams will be able to communicate. So basically that's in a nutshell. This is done. The reason for this cutout is the battery is going to be situated here, or it's going over the battery on the EPS board. There's another board like this, which is a complete PC board, where you can have the battery on top of my PC board. So it's all to do with space and weight. This weighs only 62 grams. So it's not heavy, and these, with the solar panels, is less than, I think it's 30 grams. Very light. But in any case, on this board, you also have a infrared detector situated there. It is for measuring infrared radiation, and it is will be also available in the data stream that comes down to Earth, and you can decode the value of the infrared sensor. Thank you very much.
Thank you very much.